Okay, guys. I'm not sure if Alan is here. Yes. So do you hear me, everyone? And can you see my screen?
Yes, I can see your screen.
Okay, very good. So my purpose for today's session is going over the test problems. And if the time permits, I can also begin the next unit, which is trigonometric functions. And by the way, I posted some notes on Discord for the next unit, for the trigonometry. Can you check and see if you see the notes or if you received my message on Discord?
Yeah, I see your notes.
Okay, so these are the notes. Please use them when you want to study this unit, trigonometry. I mean the next unit. So please use these notes and study them. I hope it helps. Okay, and so this is the reference for you. Okay. Does everyone see the notes from Discord? Okay, guys. So let me know if you haven't received my message on Discord. Please let me know, and I can probably email you. Okay. Okay. So just quickly, I go over the first question. First question was not too hard, I guess, for you. So the question says that, so question 1, it says that if log of 5 with base 2 is equal to s and log of 3 with base 2 is equal to t, then write each of these expressions in terms of s and t. And the expressions are basically, so the first one, let me just do B and C. So for part B is log of 0.12. So you know that log 0.12, I mean 0.12 is just 12 over 100, right? And by, you know, that this, we have this property of logs that it converts subtraction to division. So that means log of 12 over 100 is equal to log of 12 minus log of 100. And then log of 12 is what? Is just log of 4 times 3 minus log of 100. Log of 100 is log of 4 times 25. So this would be, and the base is also 2. So it's equal to log, again, log of multiplication is the sum of the two logs. So it's equal to log of 4 plus log of 3, and then minus.
Hello.
Oh, hi, Lisa.
Hi.
Hi. So I'm just going over the tests questions, okay?
Oh, okay.
And this is just question 1, part B. Okay, so okay, now log of 4 times 25 is just log of 4 plus log of 25. But log of 4, it's just 2. And by the way, because we have log 4 minus log 4, they cancel out each other. This is 0. Then you get log 3 with base 2 minus log 25. Log 25 is 5 squared. So minus log of 5 squared. And 5 squared is 2 times log 5. So it's equal to log 3 minus 2 times log 5. So this would be equal to S minus 2t. Any question about this problem?
Oh no. But this kind of question showed up in our homework and assignment. No, I think I don't remember.
Oh, I see. Yeah, you are right. So I should give you, yeah, similar questions. Yeah. Okay.
Mm.
So, and this part C is just, I mean, part C is similar. And the key is 20.25 is just 4.5 squared. So that means log of 4.5 square. This is equal to 2 times log of 4.5, which is equal to 2 points. But we know that 4.5 is 9/2. So it's 2 times log of 9/2. Right?
Mhm.
Which is equal to 2 times. So log of 9 minus log of 2. Because 9/2, log of 9/2 is just log of 9 minus log of 2. So this would be equal to 2 times. And again, 9, because 9 is 3 squared. So it's log of 3 squared minus, and log of 2 is just 1. So it's equal to 2 times 2 log 3 minus 1. And log of 3, we know it's equal to t. So if we want to write it in terms of t, it's just 2 times 2t minus 1. Does it make sense? Is it clear?
Yes.
Very good. So that was question 1, and let us go over question 2. And it is basically, I want to solve this question in 2 ways. Okay, so the question says that you have to solve this equation and write your solution in the form x equal to ln A over ln B. So solving this equation is one problem, and then writing the solution in terms of ln is another problem. Okay, so that's why I want to do this in 2 ways. So Here is solution 1. So solution 1, just take ln of this equation, of the above equation. So if you take ln, that means ln of 4 to the power 2x minus 3 is equal to ln of 8 to the power x minus 3. And again, because the properties of log, we know that ln of 4 to the power something is just 2x minus 3 times ln of 4. And same thing for ln of 8 to the power something is just x minus 3 times ln of 8. Now we do, we multiply just, I mean, you distribute this multiplication, you get 2x times ln of 4 minus 3 times ln of 4 is equal to x times ln of 8 minus 3 times ln of 8. And if you take x, ln of 8 to the right and 3 times ln of 4 to the, x ln of 8 to the left and 3 times ln of 4 to the right, then you get 2x ln of 4. And by the way, 2x times ln of 4, you can just say it's ln of x times ln of 16. Because you can remove this 2 and then put it here. Minus x times ln of 8 is equal to 3 times ln of 4 minus 3 times ln of 8. So you get x times ln of 16 minus ln of 8 is equal to ln of 4 to the power 3 minus ln of 8 to the power 3. Okay, so keep this equation. Okay, and by the way, ln of 16 minus ln of 8 is just ln of 16 over 8. And this guy is just ln of 4 to the power 3 over 8 to the power 3. Right?
Mm.
So that means x equal to, sorry, or you can say x times ln of 16 over 8 is ln of 2 is equal to ln of 4 to the power 3 over 8 to the power 3. What is it? What is 4 to the power 3 over 8 to the power 3?
1 over 2. 1 over 2,
Yes.
right?
1 over 2 to the power
3.
3, which is 1 over 8. So x equal to ln of 1 over 8 divided by ln of 2. And that's it, because the question wants you to write the answer in terms of, in this form, in this format, ln of a over ln of b. So a here is 1 over 8 and b is 2. Okay. Here we try to write the answer in terms of this, in this form, in this format. But as I said, solving the equation is another problem. You can solve the equation without necessarily write it in that format. And so let's do this. So let's just solve the equation, which is what? So 4 to the power 2x minus 3 is equal to 8 to the power x minus 3. And solving this equation is quite easy because 4 is just, we can just write 4 as 2 square. And you can write 8 as 2 cubed. And if you simplify the exponent, you get 2 to the power 4x minus 6, because 2 times 2x minus 3 is 4x minus 6, and 3 times x minus 3 is 3x minus 9. And that's it, because 2 to the power 4x minus 6 is equal to 2 to the power 3x minus 9. So that means the exponents, the powers should be equal. So 4x minus 6 is equal to 3x minus 9. And that means x is basically equal to minus 3. Right?
Mm-hmm.
But because so this is the answer, but they want us to write this in terms of 2 ln's, like ln of A divided by ln of B.
Mhm.
So how you can do it? So can you write 3 in the form ln of A over ln of B?
ln
Um,
3 over 1. No, minus 1. Can it be minus 1? No.
There are different, that's a good start. There are different ways to do this. So one way, so let me just tell you one way. So one way is just saying that we can say that minus 3 is equal to minus times log of 8 with base 2, right? Does it make sense?
Yes.
Because 8 is equal to 2 to the power 3. So log of 2 to the power 3 is just 3. That's it. And I keep the minus there. So now you can say that, okay, I can write this as, and by the way, minus log of 8 is equal to log of 1 over 8, right? And that's, we get rid of the minus. Now, when you have any log, any logarithm, you can write it as ln of 1 over 8 over ln of 2. Remember, that is one of the properties, one of the laws for logarithm. So I'm just writing here. So log of, like say, A with base B is equal to ln of A divided by ln of B. I mean, this doesn't have to be ln. It could be any log with any base. But here I'm choosing ln because the question, the problem wants me to do this. So log of 1 over 8 with base 2 is just ln of 1 over 8 over ln of 2. And that's it. Because it's the same answer. Okay?
Mm-hmm.
Any questions?
No.
Okay, let's go over question 3. Question 3a was a little bit tricky maybe, but not too bad because it wants to solve this equation. So what you can do is you can bring this to the right hand side and you can say, okay, x squared minus 9 times e to the power 2x minus 1 minus x squared minus 9 is equal to 0. Clear?
Mm-hmm.
So if you can factor out x squared minus 9. So the first expression you get e to the power 2x minus 1. And then from the second term, you get just minus 1. So you factor x squared minus. Now you have this equation. When you have the product of two things equal to 0, that means either x squared minus 9 is equal to 0, or e to the power 2x minus 1 minus 1 is equal to 0. And you can solve these two equations separately. So the first one, that means x squared is equal to 9. So that means x is plus minus 3. And for the second equation, that means e to the power 2x minus 1 equal to 1. So when you have e to the power something is equal to 1, that means the exponent should be what?
0.
The exponent should be 0. So that means
2x minus 1 equals 0.
exactly 2x minus 1 is equal to 0. So that is x equal to 1/2. So you have three solutions: x equal to 3, x equal to negative 3, and x equal to 1/2. Okay, so part B, it says that log of x equal to 0. And when there is no base, that means the base is 10 basically. So log x equal to 0. So first of all, you have two logs, okay? So first look at the first log. So whenever you have log of something equal to 0, so whenever you have log of a equal to 0, that means a has to be 1, right?
Yeah.
So from this equation, it follows that log x equal to 1. And because the base is 10, the base here is 10, so that means x must be equal to 10 to the power 1, which is just 10. Right?
Mm-hmm.
And that makes sense because log of log 10 is equal to log 10 is 1, is just log 1 is 0. That was just a quick check. Okay. So I guess question 4 is easy. I don't have to go over it.
Mm-hmm.
I mean, just the key point for question 4 is that when it says that f of x equal to minus log of 2x plus 1, so one can say that, so f of x is equal to minus then log of 2x plus 1 is log of 2 times x plus 1/2. Now we use the multiplicative property of log. Log of 2 times something is just log of 2 plus log of that thing, which is x plus 1/2. It is the multiplicative property of log that we use over and over. And another observation is that log 2 is just a constant number. Log 2, this is a constant number. Is a number less than 1. So it's like, I don't know exactly, but it's a constant number around, it's a constant number around 0.4, for example, or something. But at any rate, it's a constant number. So what you need to do is to first, so you can first draw log x and then draw log x plus 1/2. Here you just do a horizontal transformation, 1/2 unit to the left, and then you add another constant term, log of x plus 1/2 plus log 2. This is a vertical transformation because log 2 is a number around 1/2, and then you, at the very end, you just multiply it by -1. You just flip the whole graph around the x-axis. Okay.
Mm-hmm.
Now let me go over question 5. I will do part A. So or maybe it's both parts, it doesn't matter. So question 5, you have to find the range. Sorry, find the domain. Ln of, so f of x is equal to ln of x cubed plus 3x squared plus 3x minus 7. So first of all, let me simplify the expression, the polynomial inside the ln. So f of x is equal to ln of, this x cubed plus 3x squared plus 3x is just x plus 1 squared minus 1. Because x plus 1, cubed, not a square. I'm sorry. So it's x plus 1 cubed minus 1. Why? Because x plus 1 cubed is just x cubed plus 3x squared plus 3x plus 1. If you remove 1, so you get exactly the same thing. X cubed plus 3x squared plus 3x. And then minus 7. So f of x is equal to ln of x plus 1 cubed minus 8. So that was some simplification that is actually a big help. Because now, what is the domain of ln? Ln itself. What is the domain of ln?
x plus 1 to the power 3 must greater than 8, so we can solve for x, right?
Exactly. So because the domain of Ln is positive numbers, so whatever goes inside the Ln has to be positive. So x plus 1 cubed minus 8 has to be positive because of the restrictions of Ln, or in general for any logarithm. Now you have to solve this. X plus 1 cubed is greater than 8. So that means x plus 1 is greater than 2. And that means x has to be greater than 1. So the domain, we can say that the domain of f is the interval from 1 to infinity. All the numbers that are greater than 1, bigger than 1.
Yeah.
Any question?
No.
And for the next part, f of x is equal to log of 2x plus 1 over x minus 1. Again, because the domain of log is positive numbers. So 2x plus 1 over x minus 1 has to be positive. So now you have a new inequality to solve. And we discussed this a lot, how to solve this type of rational inequalities. So you just make a table. This is x. And you have to find the roots of the denominator and numerator. So the root of numerator is just minus 1/2, and the root of denominator is just 1. So you have 2x plus 1, you have x minus 1, and then you have the whole thing, 2x plus 1 over x minus 1. So 2x plus 1 is 0 when x equal to minus 1/2. It's positive here, negative here, and x minus 1 is 0 at x equal to 1. It's positive here, negative here. And when you multiply the signs, you get maybe, sorry, I am doing the wrong question. Question 5b, sorry, I wrote the question wrong. So, but it doesn't change the things a lot, don't worry. So f of x is equal to ln of 1 minus 2x over x plus 3, right? So the question is ln of 1 minus 2x over x plus 3. So you have to solve this now. 1 minus 2x over x plus 3 is positive. Okay. So what are the roots of the denominator and numerator? So the roots are basically let me rewrite this. So the roots are, the root of numerator is 1 over 2, 1/2, and the root of denominator is minus 3, and then you have 1 minus 2x, and then you have x plus 3, And then you have the whole thing, 1 minus 2x over x plus 3. Okay, now let's do this. So 1 minus 2x is 0 when x equal to 1/2. And here is negative when x greater than 1/2, and is positive when x is less than 1/2. X plus 3 is 0 when x equal to minus 3, negative here, positive here. And now you multiply, you get minus plus minus. Now, where is the solution? Solution is here, basically. We are looking for the region in which 1 minus 2x over x plus 3 is positive. So that means x has to be between minus 3 and 1/2. And that's the domain. So the domain of f is the interval, the open interval, minus 3 to 1/2. Any question?
No.
Okay. Now let me do question 9 just for fun. Has anybody done question 9?
The bonus question,
The bonus question.
I figured out the answer.
What is the answer?
Let me
Wow.
open my test.
Is it √2?
Oh, √2? No, by the way, this is the exponent goes forever. It's x to the power x to the power x, and they go on and on forever.
Yeah.
So how you do it? What is your strategy for solving this?
You know, you first say put the same log base or on both sides, log 2.
Exactly. That's a very good move. Very good move. So you first take, say we can take ln. Okay, so take ln. So if you take ln, that means ln of x to the power x to the power x to the power x is equal to ln of 2. Now, what you can say?
Then you
We use one of the properties of log.
you move
X to the power.
the exponent to the front.
Yeah, so x to power n, I mean ln of x to the power a is a times ln of x. So it's equal to x to the power x to the power x like this times ln of x. But now what? But we know this guy is equal to, what is this guy? This guy is equal to 2. Because it's an infinite exponent, right? So this guy is just equal to 2 from the very first equation. So 2 times ln of x is equal to ln of 2. So that means ln of x is equal to ln of what? 1/2 ln of 2. So ln of x is equal to ln of what? Square root of 2. Who said the answer is the square root of 2?
Me.
Ah, you solved this?
I just like write it, but
Anyway, so ln of x is equal to ln of a square root of 2, right? So x is equal to square root of 2.
Sorry, I failed to catch it.
Pardon me?
I failed to catch it. I means I don't know why. After you take the line for each side, I can't understand other steps after that.
So you have ln of x to the power x to the power x. The
Mhm.
exponent goes forever, right?
Mm-hmm.
But x to the power something, you can take it in front of ln, right?
Yes.
So you have x to the power x to the power x times ln of x is equal to ln of 2.
Mm-hmm.
But x to the power x to the power x is 2, is equal to 2. We know from the first equation.
Oh. Oh. Wow.
So 2 times ln of x is equal to ln of 2. So that means ln of x is 1/2 ln of 2, and then x is just equal to square root of 2.
Oh. Got it.
Got it?
Mm-hmm.
And let me maybe just do question 7. Question 7, the mathematical, this is a question about exponential decay, or you can say exponential growth in general. But here we are dealing with exponential decay. So we know the mathematical model is just, if m is the mass of this radioactive material, then m of t, m denotes the mass, is equal to m0, the initial mass, times 1/2 to the power t over h. And h is the half-life. Okay, so is equal to m0 times 1/2 to the power, and the half-life is 2 years, t over 2. And we know the initial mass is 500. So you have to, so the question says that at what point m of t is equal to 5. So at what time m is equal to 5? So that means 500 times 1 over 2 to the power t½ is equal to 5. So that means 1/2 to the power t½ is equal to 1 over 100. So you can do this in different ways. Either you can take ln, you can take log, whatever you want. So I just take log with base 2. So if I take log with base 2, let me just rewrite this. If you take log with base 2, then you get log with base 2 of 1/2 t half is equal to log with base 2 of 1/400. So t half times log half is equal to log or minus log of 100. But log of 1/2 with base 1/2 is just minus 1. So that means t over 2 is equal to log of 100 with base 2. So that means t is equal to 2 times log of 100. Does it make sense? So and that's the answer. So you just, that's t is equal to 2 times log 100. And log 100 is a number around, what, around 6 or 7? Because 2 to the power 6 is 64, and then 2 to the power 7 is 128. So this number is something between 6 and 7. So that means 2 times this is something around 12 or 14. So that means you have after 14, for example, after 14 years, the mass reduces to 5 milligram from 500 milligram. Okay, guys? Okay. So I posted some notes, Lisa, to the Discord. So please check the Discord, and everyone, please check your Discord and make sure you receive my notes for the next unit.
Okay.
Okay.
Mm-hmm.
And then that's it. So I will begin the trigonometry part tomorrow. Unit.
Yeah.
Good.
Mm-hmm.
Okay, guys. So I will see you tomorrow.
See you. Bye, teacher.
Bye. Have a good day.
You too. Bye.